Hello, everyone, and welcome to another mini Sky Tonight. As we continue through our solar system tour, we're now starting into the Jovian planets. Last time we talked about Jupiter, and now we're looking on to Saturn, the Lord of the Rings. So let's take a look at this amazing planet. So it was named after the god of time or in agriculture in Roman, but it's gone by different names as well. It was first recorded in the 7th century BC in Babylon, but it's gone by Phonos and Phanian in Greek culture, as well as Shabbathai. I'm probably mispronouncing that. I am sorry. I cannot pronounce Hebrew very well, but it was their version of a guiding star. In Chinese, it was considered the Earth star as a part of the Earth elements, and it's gone by different names as well. And sadly, I couldn't pronounce these names as I looked them up because ancient languages are not my forte, but I do know astronomy very well. But needless to say, Saturn has been observed for many, many years throughout time to look at the sky as a wandering star. The term planet means wanderer because it was a star that would seem to wander through the stars, when in actuality it was a body in our solar system. In fact, it was Galileo who first got to see it in a telescope. Now, I mentioned Galileo got to see a lot of things because, after all, he was the first curious person who took a spyglass and stuck it up to the sky because he wanted to see what was up there. And he discovered unique things about the sky. And so, as you can see from this sketch, Galileo's sketches of the three drawings were made through like very primitive telescope. To him, the rings kind of looked like ears on Saturn because the resolution of his little telescope was very limited. So he did the best he could with what he had. In fact, it was other astronomers like Christian Huygens and Cassini who were able to get much more powerful telescopes and to be able to figure out much further details. So some of the basic facts and numbers. 1 year on Saturn takes roughly 29 years here on Earth, or basically 29 and a half years. So Saturn's quite a long distance away, roughly about 1.43 billion, with a B, billion miles away. Now, as we get further out into the solar system, the distances between the planets get bigger and bigger. The smaller planets, like the rocky terrestrial planets, are relatively close together, given the size, but as you get towards the gas giants, they're much further spread apart. So we're looking at something that's 1.43 billion miles away, but yet we're still able to see it in our sky because our sun is that bright and that much light reflects off of Saturn. But however, just like Jupiter, 1 day on Saturn is 10.7 hours, so it rotates fast for its size. It's the second largest planet in the solar system. In fact, just to give you a rough idea, about 763 Earths could fit inside Saturn. And it's incredibly cold. The temperatures are usually roughly around about negative 285 degrees below zero. But that's on the surface. Now, like Jupiter, once you start getting in towards the center of the planet and the pressure starts to increase, the temperature goes up. It's also a Jovian planet, and it has a magnitude of 0.46, so it's relatively bright. The limit that the human eye can see is roughly 5 magnitude. Anything lower that in number means it's visible to see. Anything higher that in number, it's unable to see with the naked eye. And has 82 moons to this date. It has more moons than Jupiter. Now, it could be possible that Jupiter may indeed have a few more moons, but we don't know. But to this date, Saturn has 82 moons. It's crazy. But one of the fun facts I always enjoy about Saturn is I sometimes like to call it the rubber ducky of the solar system. And here's why. As you can see, the density of Saturn is 0.6 grams per cubic centimeter. So what does that mean? Well, density is basically taking an object's mass and dividing about how big it is. It's basically taking the object's stuff or its weight, but usually when we refer to weight, we're talking about the mass being pulled down by gravity. And we're not talking about that. We're talking about how much stuff is in Saturn over how big it is. In fact, just for a size comparison in terms of weight, you could have 1 kilogram of lead be the same weight as 1 kilogram of feathers. It weighs the same because it's 1 kilogram. I know it seems weird and crazy to you, but it's about the same weight. It just means you have to have a lot more feathers, but they weigh about the same. But when I'm talking about density, we're talking about the amount of stuff that's in Saturn spread out through the volume of Saturn. And since it's mostly composed of gas, it has a density of 0.6 grams per cubic centimeter. Now, when I mentioned it was like the rubber ducky of the solar system is because the density of water is 1 gram per cubic centimeter. Anything that has a density less than that of water will float on water. So since it has a density of 0.6 grams, that means, 0.6 grams per cubic centimeter, that means you could take Saturn and stick it in a huge swimming pool and it would float like a rubber ducky. I know it's so crazy to think of that, this huge, massive planet, as big as it is, it would float. It's mind-blowing, but it's still a fun fact I always enjoy. So let's dive in. Let's take a look at what's inside Saturn. Now, Jupiter is similar to Saturn in many different ways, but what makes Saturn different is that its layers seem to be more evenly distributed. Whereas in Jupiter, much of its upper gas layers are near the top. Many of the gas layers of Saturn are a little more evenly spread, as well as the different layers inside, like the gaseous hydrogen, the liquid hydrogen, and then possibly the core of some kind. They're much more evenly spread. It does have a huge magnetic field, possibly a metallic core of some kind, similar to Jupiter. And we have seen aurora on Saturn too, thanks to the Cassini-Huygens mission. So you take a look at the cloud tops of Saturn, you're into the stratosphere, and then you kind of get this fuzzy haze. And then you start getting ammonia hydrosulfide ice that intermix in there. And the reason being why it doesn't have as broad of colors as, say, Jupiter, Saturn's clouds are a little easily mixed, so hence why they look kind of like a similar color. But of course, Saturn is most wonderfully known for its beautiful, elegant rings. Now, the rings may look solid, but in actuality, they're not. They're small particles, some with as big as boulders to little tiny grains of sand. And these were first discovered by Huygens when he was looking and noticed that some of these rings looked like he could see light through these rings, like he could see stars through the rings. So that told him that the rings themselves were not solid. And most of these particles and boulders are rock ice. So astronomers believe that the rings were actually formed when 2 moons of Saturn during the early formations rammed together and shattered. And those shattered little pieces fell into orbit. And some of the other moons around Saturn, like for example, Enceladus, replenish the rings with their ice volcanoes. And as well as other meteorites and stuff like that that do go into the rings. So the rings are basically just material that was just collected and went into orbit. So you can kind of say they're like mini moons, but not really, because that's a lot of moons. And they may have formed after Saturn did, but we don't know. And we're hoping to find out more as we send out other spacecraft to the outer solar system. One of the most prominent features of Saturn is this dark line in the middle of the rings. This is what is known as Cassini's vision. It's a natural gap between the rings because it's a natural residence between the moons of Saturn and Saturn itself. So basically the gravity from the moons is pushing the material on the outer part towards the moons, and Saturn is pulling some of the inner material towards them, and then the gravity between them is balanced, so there's nothing that forms in there. It's a natural gap. Now, there's other natural gaps that do form because of gravitational pulls between other moons, but this one is the biggest. The Cassini's division is the biggest. Now, the rings are exceptionally thin. The average thickness of the rings is the distance between the two goalposts of a football field. So since we kind of had the Super Bowl not too long ago, imagine basically going from one end of a American football field to the other end, and that is the thickness of the rings. They're not very thick, but they're exceptionally long. The length, like the circumference of the rings, is roughly about 1.8 million miles. So if you had your fastest racetrack runner, like the fastest you could ever run, and hoping you have the best shoes possible, and you're going at the fastest speed possible with no stops, no water breaks or anything, it would take you 5 years to make one lap around the rings. And if you had the fastest car, it would take you nearly 362 days, almost a year, to complete one lap. That's assuming that you're driving the speed limit and everything. But if you were traveling in the fastest car, if I did my calculations correct, it'd still take you a half a year to make one lap. That's a pretty big circuit for even the fastest car. But one of the unique features of the rings that still baffle astronomers is these supposed spokes that appear and disappear with the seasons. Yeah, this image I wanted to show you. The rings are exceptionally thin. So sometimes when you see the planet Saturn, you can't see the rings at all. But these are the spokes I wanted to mention about. They were first discovered by Voyager 1, and they noticed that over the course of time, with the rotation of the rings, there was these dark areas that would rotate with the planet. But over the course of years, some of those dark spots have disappeared, as you can see with the image on the left with the Cassini-Huygens spacecraft. So astronomers think they're seasonal, but we're not sure what causes them. So let's take a look at the atmosphere as a total. It's mostly composed of hydrogen, helium, ammonia, methane, water, and sulfur compounds, similar to that of Jupiter. It has band layers, but they're harder to differentiate because since it's much colder, some of the material starts to mix. So it's really hard to see the nice differentiated bands of Saturn. And it also goes through a process known as methane photolysis. Basically, what's happening is that photons from the sun interact with the methane in the atmosphere and break it apart into its many components. It's kind of like how our ozone is created. Basically, photons from the sun interact with our atmosphere and break oxygen apart and or combine it together to give us the O3 for our ozone. That's kind of what's going on here in Saturn, and maybe why we don't see the differentiation between the different cloud layers because of this methane photolysis. And one of the unique things that we have recently discovered thanks to the Cassini-Huygens spacecraft is that occasionally you get global storms. Kind of like the storms that you see on Jupiter, the Great Red Spot, but these don't last very long. They last at least only 1 or 2 weeks, whereas in the Great Red Spot has lasted for several years. But you'd get to see occasional storms that cover the majority of the planet. So it's really unique just to see the atmosphere of this planet. But one unique feature that has baffled astronomers for multiple years is this particular cloud, and it's only on the North Pole of Saturn. It's called the HEXAGON cloud, and it's a anticyclonic tropical storm, kind of like the Great Red Spot, but it's only at the pole. It's known since Voyager 1, but they didn't know what caused it. Because normally the Great Red Spot was due to high pressure, low pressure zones, but most of the time at the poles, there's nothing of that nature. And it's only at the North Pole. The South Pole basically has a circular vortex versus this has a hexagon. Now, scientists at Cambridge University were able to do some models in the lab, and they came up with two possible ideas what causes this unique cloud structure. Is that there's jets alternating in the shallow parts of the atmosphere, and or it's deep zonal jets. And they lean more towards the deep zonal jets because they were able to replicate that hexagonal shape when you have some deep zonal jets going on, and basically with materials being heavier in some parts and lighter in some parts, you start getting weird shapes. Now, keep in mind, this cloud is big. Like one side of the hexagon is 9,000 miles. And just to go from one side to the other, it's 18,000 miles. That's crazy. So let's talk about visits. What have we sent to Saturn? Now, keep in mind, we have sent other spacecraft, like one of the spacecraft that did take a few images of it was the New Horizons spacecraft, but its primary mission was to go to Pluto. Its primary mission wasn't to check out Saturn. It was a secondary mission. So I'm only going to talk about the primary missions that are going to Saturn or have gone to Saturn. The first one was Pioneer 11, where it did its first flyby mission to take a look at the planet itself, its beautiful ring system, to get an up close and personal view, and to look at some of the different moons. Voyager 1 did a nice detailed view of the rings and the planets, because Voyager 1 was supposed to go further into the solar system to look at different things like Uranus and Neptune, but it had some technical difficulties. Like I think it was one of the motors that failed, and it couldn't get out of orbit. So they just kept it into orbit around Saturn to get a bunch of pictures of the planet, including the rings and the spokes, and several images of the different features of the rings themselves. Voyager 2 came along, and it was able to take a bunch of pictures of the moons, especially Titan. Titan is the only moon in our solar system to have an atmosphere. And I did a video on that particular moon. If you'd like to see that video, I'll leave a link up here somewhere so you can check out that particular moon. And then, of course, we had the Cassini-Huygens spacecraft, which was the longest mission possible. It was there for several years, and it looked at many of the moons, including Enceladus, Dione, and many, many, many more. And Iapetus, Iapetus is a really cool moon. It's basically one side is dark as asphalt, but the other side is light as snow, and it's really unique. And it was Cassini who confirmed the new number of moons. And we landed a probe on a moon. We landed a probe on Titan. So it was the first time we have landed an object on a different moon in our solar system. And we're hoping to send another spacecraft out there, this Saturn Atmospheric Entry Probe, to understand, kind of like with the Galileo probe with Jupiter, to understand what's going on in the atmosphere of Saturn. So where can you see it? Well, for you early morning risers, the best time to view it is in the early morning, just before sunrise. You can see the planets Jupiter, Mercury, and Saturn close to the eastern horizon in the early morning. So if you have a pair of binoculars or a small telescope, take a look at this planet. You'll definitely get to see the beautiful rings and a couple of the different moons as well. If there's a topic you would love for me to cover over, folks, leave it down in the comments. If you have any questions or comments, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.